Hi grade 10s, this is JP, and we are going to start off by looking at what is trigonometry. It's just a brief intro, and this video will allow you to do activity 1, 2 and 3, ultimately then 4 and 5 as well. And so yeah, this is just the intro. Trigonometry is one of the most useful branches of mathematics. The word trigonometry comes from two Greek words, trigonon, meaning triangle, and metron, meaning measure. So it studies essentially the relationships between the lengths of the sides of triangles and then the angles between those sides. So trigonometry uses triangle measurements to work out heights and distances, including the distances between things that's very difficult to measure, things that's incredibly big or far apart or very small. Like the stars, it's kind of difficult to measure it with a tape measure. So this is one way that we can find the actual distances. Trigonometry spreads its applications into various fields such as engineering, architecture, surveying, or astronauts, physicists, and then even crime scene investigators. So you'll see I'm never sure, the GIF, the GIF below is showing the Babylonian tablet. It's known as Plimpton 322. It's a table filled with sets of Pythagorean triplets. Do you guys remember what's Pythagorean triplets? It's all the so in a 90-degree triangle is when we can use Pythagoras. And remember, Pythagoras essentially says, well, it's a sum of the short sides of a 90-degree triangle square, and that is equal to the hypotenuse, the longest side squares. In other words, a squared plus by b squared is equal to c squared. So it's just, so this is very old, but before my time, and it shows they never knew what was on this table, and they reckon it's they understood it as the Pythagorean triplets, and what it shows here is, and just that triangle on the right hand side as well, is how if the sides changes, how that affects, of course, the angle between them. Right, so I'm not sure how many of you are familiar with Greek. This will look a bit Greek to you. But although when I was in school they told us it was Pythagoras that he was the one that found trigonometry, and so it's the Babylonians that it's 1,000 years before Pythagoras, still freaking long time ago, but that they need to deserve all the credit. So what can we do with trigonometry? Why is this such an important part about in our mathematical work, our understanding of the world? It's well, the first thing is it might seem as a very stupid thing, but it's to see if triangles are possible. So possible triangles, right? So if I ask you, is it possible first of all to construct any triangle? I think the answer of that would be yes. But if I ask you, so we're only going to study 90-degree triangles this year, right? There's, of course, other triangles as well, but we're only going to focus on 90-degree triangles, the right-angle triangles this year. Is it possible to draw a triangle where this is like 5 centimeters and that's 12 centimeters and that angle is 30 degrees? Is that possible? Is it possible to draw a triangle if that is 30 degrees and then that length to be 5 and that length to be 9? Are those possible constructions? So that's one thing we use trigonometry for. The other part is this is the very cool part, is if you've got any side in any given angle. So in other words, if you know this, for example, is 9 meters, and you know this angle is 30 degrees, you can find out any of the other two sides. So either this one or that one. So if you've got a given angle and you've got a side, you can find out the size of any of the length of any of the other sides. The other cool thing is if you've got any two sides in the 90-degree triangle, for example, you've got those two, you can find out any of the angles. Right, that's the relation. That's what I'm talking about. The relationships between the size of the lengths of sides and then the size of the angles. Okay, so let's get this running. So what I want you to do is open or look at the PDF that says activity 1, 2, and 3. And so the idea about this is for you to discover trigonometry, for you to for us to create a scenario where you can see and define the relationship between sides of a triangle and given angles. Okay, so the first part, just a couple of things we need to get out of the way. I told you it looks a bit Greek. It's just we use the Greek alphabet letters in trigonometry. It's just a default. So of course, so this is theta. It's just a variable, so you're probably not very good. My handwriting is terrible. That's theta, beta, of course. Then we get alpha, beta, gamma, delta, epsilon. Yeah, just go and look at the Greek alphabet. I mean, it's not that important. So, like normally in algebra, we would use x and y and z, right? The majority of times here, we would use theta for angles, or beta for angles, and that's kind of the big deal. And then we've got alpha, or we can but we can, those are just variables that we sometimes use. Okay, then the second thing is very important here is just to look at the terminology. So this is on the first page of that activity 1, 2, 3 PDF. So in any 90-degree triangle, there's of course, it's a right angle 90-degree triangle because there's a 90-degree angle in it, right? So this can, for example, be theta, and that can be beta. Okay, so it's just names we give those angles. Okay, so it's all about the reference angle here. The reference angle is incredibly important. Okay, so you'll say the adjacent and opposite sides are always with respect to the reference angle that you're working at. So how this works is the longer side of a triangle will always be the hypotenuse. So the hypotenuse of a right angle triangle is the side opposite the 90-degree angle. So that's called the hypotenuse. Okay? And then the reference angle. So say, for example, if my reference angle is theta, okay, then how we would label it is the angle closest to my reference angle, the side closest to my reference angle, but not the hypotenuse, is my adjacent. So that's the hypotenuse, okay? The side closest to the reference angle, but not the hypotenuse, is the adjacent. So that is my adjacent. Well, think of adjacent walls, it's adjacent to that angle. And then the one opposite that is called the opposite, right? If I've got a right angle triangle where beta is my reference angle, so how would that change? Again, the hypotenuse stays the hypotenuse, right? Yeah. The side closest adjacent to that angle, but not the hypotenuse, is of course called the adjacent, and the one opposite that is called the opposite. Does that make sense? In activity 1, what I want you to look at is there's two triangles drawn there. The first triangle, triangle ABC, we've got B is your 90-degree triangle, and then we've got lengths. It doesn't matter about the units of these. They are, we'll talk later about this, about the similarity aspect of trigonometry. Don't worry too much about units now, but we know that, okay, so this length is 5, and that AC is 10, and then that BC is 8.6. So what I want you to do is, so in other words, write down the lengths of the following sides. So if my reference angle is 30 degrees, what is the opposite side's length going to be? What is the opposite side if that's my reference angle? Of course, it will be BA, right? AB. That's going to be 5. What happened to this 5? And then adjacent, the adjacent will be, well, then if that is my reference angle, right, that's my opposite, that's my adjacent. Why? Because AC is my long one, the hypotenuse, right? So the hypotenuse then will be 10. Okay, so please do it for 60 degrees. Okay, so if this is Just ignore me if you know how to do this. If that's my angle, well, then this is going to be my adjacent. That is my opposite. The hypotenuse, of course, will stay the hypotenuse. So if my reference angle is 60 degrees, the opposite side is now going to be 8.6. The adjacent side is going to be 5, and the hypotenuse is going to be 10. And then we look at the other triangle, the one on the right. You can see it's an isosceles with a 90-degree angle. So if my adjacent side is 45, and how does this work again? I mean, that's just a square, right? Very badly drawn square, anyway. And there's a diagonal drawing that's been drawn through it. Of course, the two lengths must be the same. Same size. All right, so 45 degrees, it doesn't matter which one you look at. My adjacent would be, if you look at this angle, that will be my adjacent and that will be my opposite, and that's my hypotenuse. My adjacent will be 6, my opposite will be 6, my adjacent will be 6, and my hypotenuse will be 8.5. Okay, so what I'm not going to do this with you now, but I want you to divide then the lengths of the opposite in each of these rows. The length of the opposite divided by the hypotenuse. In other words, I'll do the first one for you. So in other words, the opposite there is going to be 5 for if the reference angle is 30, and the hypotenuse is going to be 10. Okay, so that answer is going to be 0.5. Cool. And then you just do that for each of those boxes. Okay, so in the second part of activity 1, you will see that there's use your calculator to work with the following ratios. Calculator must be in degree mode. So if you're not familiar with that, so just double check on your so it's probably best to have a CAS0 calculator. I think it's much more user friendly than some of the other models. There must be a D there for degree mode on the top. If it's not there, you just press Shift and mode setup, and then just select degree mode. Okay, so in each of these, you're just going to plug in the angles, the reference angles, the sine of 30 on your calculator. So if you press sine of 30 on your calculator, you're supposed to get 0.5. And if you press cos of 30 on your calculator, you're going to get square root of 3 over 2. What happens then is, do you see there's a button there? It says S2D. So I heard someone else the other day saying that's the STD button. It's not that dangerous. It's just surds to decimals. So you just press that, and then you're going to get like 0.87 or whatever. Okay, so you just put all of this in your calculator, so that's not too bad. It's just a typing exercise. The third part of the investigation, it's just a summary. You need to conclude what you've seen, right? And so to make a conjecture about what have you noticed about the ratios of sine, cos, and tan of a reference angle, and then you just use the words so adjacent, opposite, hypotenuse, and just to fill this in. So the sine of an angle is equal to the what side divided by the what side, and the cosine of an angle is equal to the what side divided by the what side, and then the tangent tan of an angle is equal to the what side divided by the what side. So and then you just fill this in, that part there. Just fill this in, and of course you use part 1 and part 2, those two pages before, those two tables before, to make that conclusion. I will show the answers to these in the next video.